Hi everybody, my name is Lucas Chen, and this is Physics Lab 1, Constant Velocity. Here's a quick rundown of what the lab involves. So what is the purpose of this lab? The purpose of this lab is to compare the observed position of an object traveling at a constant velocity to the predicted position from a computational model. This lab uses two softwares, Tracker and GlowScript. Tracker will be used for the observable position model, where video capture of the object moving will be placed into the software to track the change in x and change in time, and GlowScript will be used to simulate the motion of this object. This lab uses Newton's second law and other formulas. Newton's second law is an important concept which states that the change in momentum is proportional to the change in time, and on the right is the position update formula, which will be utilized later. So let's get to the main portion of this lab. As you can see right here, the object is in motion and travels to the right, and as this happens, a graph is generated showing the change in position as it relates to time, and it also generates some data points. And so taking these data points, I can then put Newton's laws into action. So using the formula V average equals change in R over change in time, I can find V average to later plug into the computational model. But first of all, to find change in time, that's simply the time observed in the video, and the change in R is taken from this data set that we receive from Tracker. And finally, using this formula, you receive 1.047 meters per second, which is a reasonable amount of time for this bottle to be traveling. So for the computational model, there is a few things you have to set up before it can run. As you can see, ball velocity, using what we calculated in the previous step, we can initialize the initial x direction, x velocity, to be 1.047 meters. Change in t is 1.27. As you can see right here, this is the position update formula, and our values are then plugged in. And after that, running this program yields this model. As you can see right here, this simulates the motion of the water bottle rolling, and it's pretty accurate, and it also generates a position versus time graph. So taking these two models, we can compare their data points. In the red is the computational model, which is a linear constant slope, compared to the observational model, which has some variance, as you can see. The reason for this variance could be a number of factors. This could include air resistance, friction, or human error when I manually track the center of mass points. Moving on, here are some what ifs. What if we were to flip the axes, such as the x and y axes? In these cases, it would instead generate a negative slope, but very different depending on if it's x or y. Lastly, what does it mean? Is it possible to say how many pushes and pulls are added together to give zero net force in this lab? For this, I would say no, because there are almost an infinite amount of forces acting upon the system. For example, air force, friction force, as well as gravitational force, which all objects exert on one another. Therefore, there's an infinite number of pushes and pulls, and it cannot necessarily be added together to find the net zero force.